right, in this video, I am going to show you guys how to do a dilation from a point on or inside the figure, okay? Not from the origin, from a point on the figure itself. So again, let's review what a dilation is. A dilation is a transformation that produces a figure that is the same shape as the original, but not the same size. So it will have the same angle measures, and it will be proportional, but it won't be the same size, so it is getting bigger or smaller. All right, so we are going to do a dilation of these two triangles. We're going to start with the top one, though. Okay, so this one up here. And the question it gives us says, dilate triangle ABC by a scale factor of 1/2 from point B. Okay, so what is our center of dilation? Point B, right? From point B, and our scale factor is 1/2. Okay, so I'm going to put a dot at point B so we remember we're dilating it from here. Okay, so if you guys remember, when we're doing it from the origin, we just multiplied the coordinates by the scale factor. And this one, we can't do that because if we multiplied our coordinates, we would be dilating it from the origin. And I want to do it from point B. So instead, what I'm going to do is I'm going to find the distance between point B and the other points, and I'm going to multiply that by the scale factor. So to get from B, which is our center of dilation, to A, what did I do? Let's see, I went up 1, 2, 3, 4, 5, 6, 7, 8. So to get to point A, I went up 8. Okay, let's see, to get to point B, what did I do? To get from B to B, I did nothing. So I'm just going to do 0. I moved it 0. I didn't move it at all. To get to point C, I went over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So to get to point C, I went right 12. Now I'm going to take each of these, which are distances. These are not coordinates. These are distances. And I'm going to multiply the distance by my scale factor. So the scale factor it gave us, again, was 1/2. So we're going to take each of these and multiply them by 1/2. Now I'm going to show my work on this one. So I'm going to do A prime. I take 8 and I multiply it by 1/2. You might remember that you can just write that, 8 over 2. You just multiply straight across. 8 times 1 is 8. 1 times 2 is 2. 8 divided by 2 is 4. So my new A prime, I keep the direction. So I'm going to go up 4 from my center of dilation. So from my center right here, I'm going to go up 4. 1, 2, 3, 4. Right there. And that is my new A prime. Okay, let's do B. B prime, I'm going to multiply 0 by 1/2. It's going to give me 0 over 2, which is just 0. So B prime is not moving at all. B prime is in the exact same spot as B. B prime did not move. So I'm going to move that up so you guys can see it a little better. And last but not least, I'm going to do C prime. C prime says, oh sorry, I'm going to write move 0. So if you're following along, that makes sense. Okay, C prime says I went right 12. So I'm going to take 12 and I'm going to multiply that by 1 over 2, which will give me 12 over 2, which simplifies to be 6. And I'm going to keep the direction. So I'm going to go right 6 from my center of dilation, which is B. 1, 2, 3, 4, 5. 6 is right there, and that is C prime. And I'm just going to connect my shape. I will do it in blue so you guys can see it a little bit better. All right. So that is a dilation of 1/2 around point B. Okay? And you notice A prime and A are on the same line, C prime and C are on the same line, and B did not move. If I dilate it around a point that is on my actual figure, that point will never change. Okay? All right, so let's go look down here at this next one. So the next question says, dilate triangle, that's supposed to be an L, I'm sorry. Dilate triangle LMO by a scale factor of 2 from point L. So LMO by a scale factor of 2 from point L. So I'm going to put a dot at point L to help us remember. That's where we're dilating it from. And I want to do a scale factor of 2. Now I'm going to start by doing the same thing. How do I get to M? Let's move it up. How do I get to M from my center of dilation? It looks like I went right 3. Okay. How do I get to L? I didn't move at all, so I moved 0. And my last thing, how did I get to O from L? I went down 1, 2, 3, 4. So I'm going to write down 4. All right, so I do the same thing. I multiply the distances by my scale factor. So to find M prime, I'm going to multiply 3 by 2. Right? Wasn't that our scale factor, 2? Wow, that looks really bad, but 3 times 2 is 6, and I keep my direction. So I'm going to go right 6. So from L, I'm going to go right 6. 1, 2, 3, 4, 5, 6. And that is M prime. Okay, let's look at L. L is 0 times 2. Was my scale factor 2 or 3? Now I'm second guessing myself. Okay, it's 2. Okay, 0 times 2 is 0. So I'm going to move 0, which means L prime stays in the exact same place. And my last one I need to find out about is point O. So O prime said I went down 4, so I'm going to multiply that distance times 2. 4 times 2 is 8, so I'm going to go down 8. So I start at my center of dilation, which is L, and I go down 8. 1, 2, oh, you can't see that very good, 3, 4, 5, 6, 7, 8. And that is O prime. And now I'm just going to connect my shape. I'm going to connect this one in pink for you guys. So my dilation gave me a figure 2 times as big. Twice as big because my scale factor was 2. And again, all I did was I took the distances from my center of dilation and I multiplied those by the scale factor. And then I just graphed my new point. Now I do want to point out something on this one. So in this one up here, we dilated our original, which is the red one, by a scale factor of 1/2, and it got smaller. Do you see how 1/2 makes it smaller? In this one, we dilated it by a scale factor of 2, and it got bigger. Okay, so what you guys should notice is that if I dilate something by a number that is less than 1, so any fraction less than 1, it will be a reduction. It will get smaller. If I dilate something bigger than 1, so making it bigger than 1, that is called an enlargement. It is getting bigger. Okay. A scale factor of greater than 1 is an enlargement. A scale factor less than 1 is a reduction. All right, and that is how to dilate something from a point on the figure itself.